Hello everyone. In this video, we'll learn how to find the pressure at a point inside a liquid, a key concept in physics that helps us understand how fluids behave. I'm Pankaj Sharma from Brainleague Learning, and I'll explain this topic in a simple and easy to understand way. So let's get started. We are going to build an intuitive picture for pressure at a point in a liquid at rest. Here is our topic. Consider a clear tank of water. The top is the free surface exposed to the atmosphere. We will call the pressure at that free surface P0. Now pick a point under the surface. We will measure its vertical depth from the surface and call that distance h. We will draw the depth arrow h from the surface down to the point. Inside a fluid at rest, pressure at a point pushes equally in all directions. When a liquid is at rest, pressure increases linearly with depth because the fluid below must support the weight of the fluid above. Imagine stacking very thin horizontal layers of fluid. Each extra layer adds weight. This leads to a differential relation. dP equals rho g times dH. Integrate from the free surface at h equals 0, where the pressure is P0, down to depth h. You get the basic formula P equals P0 plus rho gh. This formula passes two quick checks. At the surface, where h equals 0, P equals P0. As you go deeper, h grows and P increases linearly. The slope of P versus h is rho g. Let us summarize the variables in the formula. P equals P0 plus rho gh. Here, P0 is the pressure at the free surface, rho is the density of the liquid, g is 9.8 meters per second squared, and h is the vertical depth below the surface. Only the vertical distance, h, matters. Now a quick example. Suppose the surface is open to the atmosphere, so P0 equals 1.01 times 10 to the 5 pascals. The density is 1,000 kilograms per cubic meter, g is 9.8, and h equals 5 meters. Compute rho gh, which is 1,000 times 9.8 times 5 equals 4.9 times 10 to the 4 pascals. Then P equals P0 plus rho gh equals 1.01 times 10 to the 5 plus 4.9 times 10 to the 4. That gives about 1.50 times 10 to the 5 pascals at 5 meters depth. Key ideas to remember. Pressure at a point acts equally in all directions. Only the vertical depth h matters, not the shape or the amount of fluid to the side. If the density or gravity changes, update rho or g in the formula.